We're going to be embarking on a journey into 2D game development inside of Unity. So I wanted to pull up a couple of examples. On the left, I have a game called Minute, and on the right, I have a game called Celeste. Recommend checking out both of these games, playing them, but they'll give you an example of the types of things that we can create with the same underlying technology that we're going to learn about called tile maps in Unity. So on the left, I have a game called Minute, which is this top-down style where you can walk around and explore the world, and you can see there's physics, so the player can't move through areas that have colliding bodies around them, multiple screens. It's kind of a similar style to some of the earlier Zelda games. And on the right side, I have Celeste, which is more of like a tough as nails story platformer game. And so we're going to be making something that's a little bit closer to Celeste than Minute, but just know that the stuff that we're going to talk about applies to both of these games. So let me pull up another reference here. So this is from a post that I wrote about tile maps in another game engine, but the same concepts apply, and I wanted to use some of these images. So here I have an image that I pulled that it shows all of the map of World 1-1 from Mario. And if we were to take this and think about this, how could we make this in terms of a game? One naive way would to take this whole giant image and just like load it in the world inside of Unity, but that has a lot of downsides. One is that the graphics cards have a limit on the maximum size image that they can handle and will probably eventually bust past that limit. Like this is already 3,500 pixels wide. So if we have much bigger levels, we'll eventually run into those limits, but also this isn't a very intuitive way to model the world because, what if we want to know, is the player standing on top of this pipe? Well, then we'd have to think, like, are they over this pixel? Or if we want to know if they're over this pipe, are they over this pixel? And we'd have to like measure that out and calculate it. Not a great approach. So introducing a more smart approach would be using something called tile maps. So I've grabbed a tile map here that is remixed by Arrow, and this is one of this has like the Lego building block pieces to make the level that we see up here. So the idea of tile maps is let's design a bunch of modular assets that we can use to build multiple types of levels, like essentially endless arrangements of levels from these pieces. And then if you care about the performance side, one of the real advantages here is this is the only thing we have to send to the graphics card in terms of textures. We send this one texture, and then by sending vertices and UV coordinates, we're able to reconstruct this whole level from that single texture. So with that in mind, why 2D? Part of the reason why developers will often go with a 2D style is because it is fast to develop, which also means that the cost of developing it is lower than having a full 3D pipeline. And then, why learn 2D as a game developer yourself or a game designer yourself is that think of it as you should have an idea of how the workflow works for both 2D and 3D games. That will make you a much stronger candidate leaving Columbia and going out in the world. So let's get started. Let's jump into Unity and see how to actually make some of this. So when you create a new project, instead of choosing 3D like we were doing before, choose 2D template. I'm going to throw this into my class materials folder. We are in week 10. Call this platformer demo. You need to pop open. We'll have a slightly different setup. Like you can see that there's no directional light inside of our scene, and our camera is set up to be orthographic instead of perspective, which we're maybe more accustomed to at this point from working in 3D, seeing perspective. But this will give us enough to work with. And then what we're going to do is grab this asset pack. So this is from Pixel Frog. It's Pixel Adventures 1. It has a bunch of cool assets that we'll be able to use to make a little platformer. So we'll use this main character. It also includes a tile map. It includes some animated images like for the apples and collectibles and things. So I'll have this link in the canvas, but you can also grab it from here. I'm going to scroll down to the bottom. I'm going to click download. And what we want to do is grab this, unzip it, And we are going to import this into our Unity project by just dragging and dropping it into our project over here. So dragging the unzipped into assets. Take a second to import. And when it's done, we'll be able to do a little bit of configuration to make sure that those images are actually set up for Unity. So we need to do two things. One, we need to change all of the settings on, or we need to change some of the settings on all of our images to configure them well for a 2D game. And then two, we're going to have to actually slice up some of these images. So for instance, if I go to double jump, this is actually an image that has multiple images inside of it. So there are things called sprite sheets and there are things called tile maps that have this structure. There's also a third type called atlases, but we're not going to talk about those today. Basically, you need to configure Unity or whatever game engine you're using to know about the different frames that are inside of the image. So first up, let's go ahead and configure this so that all of our images have the right settings to look crisp inside of our 2D world. So I'm going to grab this guy, I'm going to scale him up, and we can see that this looks really blurry and pretty awful. And if I go to click on that image, some things that I want to check and make sure as we're going through the settings, I want to make sure that the image is set to sprite. And then down here, wrap mode, I want to make sure it's clamp, and then filter mode is the one that's giving us these scaling artifacts. So this filter mode actually is good for 3D textures, but bad for pixel art where we want it to look really crisp. So you click point, no filter, apply it, and you'll get really crisp looking pixel art. It's a little tedious if we had to go through and click on each of these images and change the setting. So I'm going to show you a way to do this in bulk. I'm going to revert what I did here back to bilinear, and then what I'm going to do is click on my folder for Pixel Art Adventure, and then I'm going to use the filter over here to just get all of the textures. Didn't look like it actually picked up my selection, so I'm going to go click on search here, choose Pixel Adventure 1 so that I only have the things inside of what we just imported, and then I can hit Control A to select them all. And then my filter mode, I can change them all to point, hit apply, and now I have set up all of these sprites to work inside of my 2D game. So now what we need to do is slice up some of our images that actually contain multiple frames in them. So for instance, if I grab idle and I try and drag this into my scene, we get something that's not super helpful. We get a bunch of individual frames drawing in our scene. And that's because idle is an image that has multiple frames in it, and we need to tell Unity that there are actually multiple frames so that we could then use this to create an animation that actually runs through the individual frames. Same deal with our terrain. It's not super helpful to just like drag these tiles into our world. We actually want to slice them up so that we can use with the tile map tools to actually build levels from these pieces. So I'm going to go ahead and delete these, and let's go with our idle here. When we want to slice something up, we want to make sure that we have the texture set to sprite, and then sprite mode, we want to set it to multiple. And then we can hit apply and open up the sprite editor. And so the sprite editor lets us do a couple of things, including slice up images so that Unity knows about the frames. And there are two ways to slice. We could slice by cell size, we can slice by cell size, which is how big each individual frame is, and we can slice by the number of frames. So we could pass in how many rows and columns there are here, but since Pixel Frog has given us the size of an individual frame in here, we can just put in 32 by 32, hit slice. You'll see little outlines around your sprites. I'm going to hit apply, and then I can actually click on these to know that I've actually sliced them up properly. These boxes are fitting around all of our sprites, which if I close this now means that when I hit this drop down next to idle, I can actually grab any one of the individual frames and bring it into our scene independently, which is what we want. We want to be able to do that later to then rig up an animation that runs through all of these frames. So while we're at it, let's do the same process for our terrain so that we can have this set up so that we can use it as a tile map. So we're going to choose sprite, we're going to choose multiple, sprite editor, and then in here we are going to slice by cell size, and the cell size here for this image, again, Pixel Frog was very kind to us and put the pixels in the image, so it's 16 by 16. Hit slice, hit apply, and you can see the outlines are lining around our sprites, our tiles perfectly. I can click and select the individual ones, so we should be good to go here. basically at this point in the tutorial, I'm going to pause. I'm going to slice the rest of the images that I need to slice. And so you should do the same. If you want to use Pinkman instead of Fridge Roll Guy to follow along, make sure that you slice any of the images that have multiple frames in it. I'm going to use Virtual Guy, so I'm going to take a break and slice all of these. So everything is sliced on my project. Hopefully you followed along. I'm going to clean this up, and then we can get ready to actually build our tile map. Let's get started with the tile map, and before we actually do anything in Unity, let's check out the Unity manual, because the manual is actually really helpful for working in 2D. So here I have the manual pulled up on the sidebar. I have checked under 2D the tile map section, and there are a couple of things, new components that we're going to have to use to actually make a map using tile maps. So we scroll down to the bottom. They have this nice outline of the workflow that's involved in creating a tile map. So we're going to create a tile map game object, and an individual tile map game object represents kind of a layer in your world. So you could think of it as we're creating a bunch of platforms using the tiles. That goes in an individual tile map game object. There's the grid game object that comes along for the ride automatically when we create a tile map, and it helps align things to a grid. Since a tile map is this grid-based system, we are going to need to create tile assets and a tile palette. And so a tile palette is essentially like your palette composed of a bunch of sprites that you can paint into your world to compose a level. So we will get our tile map, or our tiles, and put them into a tile palette so that we can then paint in our world with them, which is what we'll do here. And then we will also, since we're going to make more of like a platformer type game, we'll make sure to add colliders to our tile map so that things can interact with the individual tiles. So let's flip back to Unity and do this. So I'm going to go back to Unity, and in my scene, I'm going to right click. I'm going to create a 2D object, and I'm going to create a tile map. You can see that's going to give us a grid and a tile map. So remember, the grid is the thing that helps align elements to a grid. If we select it, we can see the grid. And then we've got our tile map here, which is an actual layer of tiles that we're going to paint in the world. And you'll be able to create multiple layers, so you could have like a background and a ground. Let's call this our ground tile map. On Windows, if you press F2, you can rename it, or you can come over here after selecting it and rename it up there. So we've got our tile map. Now we need to create our tiles and tile palette, and we're going to need to open up a new window to do that. So if I go to Window, 2D, Tile Palette, bring it over onto this monitor. So we're going to create a new palette, and it will be composed of all of the tiles that are inside of our terrain tile map here, tile set. So what we're going to do, create a new palette. Let's call this our Pixel Frog Terrain Tile Set. It's going to ask us where to save it. So in the assets folder, I'm going to recommend that we create a tile palette folder. And then once we've got this palette set up, so if I look in my tile palettes folder, we can see there's this new game object. To actually fill this with tiles, we need to go ahead and grab our terrain and drag it in here. And it's going to ask us where to save the tile assets. So what I'm going to recommend doing is inside of our tile palettes, let's create a new folder, call it tiles, select this folder. It's going to take a second to generate all of the tiles. And when it's done, we'll take a peek at it over in the project view to see what it's created. So you can see we've got this game object that is our tile palette, and it's composed of all of these individual tile assets. And if I click on one of them, you can see that there are a couple of things. We've got a preview, we've got which image it uses. We can actually tint it and change its color. And we can change aspects of its collider. So we don't need to mess with anything here just yet. So we've got to change one more setting with our images to get this working. So this tile palette, we'll go over it in a second, but if I just like select a tile and make sure that I have our ground tile map selected here as the active thing that I'm painting within, and I draw some stuff, you can see wow, that doesn't look right. We've got this thing that's taking up a minuscule amount of our grid. And so what we need to do is go to our terrain, and the pixels per unit setting here determines how many pixels from this image should fill one grid unit in our world. And so since this is a 16 by 16 tile set, instead of saying that 100 pixels should fill one grid unit, we want to make sure that it's 16. Then hit apply, and now we've got our tile palette changing scale and the things in our world actually filling up the grid. So let's run through the tile palette tools now that we have our terrain set up properly so that we can draw from the terrain tile set. This tool up here, the first one, allows us to select an area of the grid, and the hotkey is S. So I could click and drag to select an area of the grid. And then if I wanted to, I could use the second tool, which the hotkey is M, the move tool, to actually move that selection around. So that's helpful if we like drew a platform and we wanted to shift it over slightly. The third tool here, the hotkey is B, is brush. So whatever we have selected, we will go ahead and draw that. So I can grab an individual tile and click to paint it over in the world. Or if I want, and things are set up in our tile map really nicely, I can select multiple things by clicking and dragging, and then I can kind of stamp them out in the world as needed. The next tool is painting a filled box. The hotkey is U, so if I grab something and make sure I've got this selected, and then click and drag, we can see that whatever I have selected is going to try and fill in to the box as I'm clicking and dragging here. The next one is the pick tool. So the hotkey is I. If I click on something, that will now select that tile. So if I paint with it, we will now have that. The next tool is the erase tool, which allows you to click and drag to erase something from your scene. And it actually will use whatever size selection you have over here as the bounds of your erase. So if I select a rectangle and then use erase, I can erase kind of a whole area. The last tool here is the paint bucket tool. So if I grab a tile, this will fill a region with that tile. So ran through them fairly quickly. The Unity documentation here, if you go to the painting on tile maps section, has a nice walkthrough and has a diagram of the hotkeys along with some tips like if you're in the paintbrush tool, you can hold shift to temporarily switch to erase, or hold control to get the picker tool, and has a little bit more explanation of each of the tools. So I'll definitely make sure that that's posted on the canvas along with this video. So if we scroll up to the top here, one thing that it points out is that we are selecting a particular tile map to draw to. So let's actually create two in our world so that we can kind of see what's going on here. So let's go ahead and delete everything. So I'm just going to use the erase tool here, delete everything that's in here. I'm going to now select one of these platforms with the brush tool, paint a couple in the scene here, and then let's say we want to use one of these other, like maybe we'll use the brick as our repeating background behind our scene. You can see that if I try and paint, like I want these tiles to be behind the other tiles that we created, but that's actually not going to work right now because we only have one layer that we can draw to, and so there can only be one tile at each of these locations. And so what you want to do, instead of pasting these in like I did, is we want to go back to our scene here and click on grid, create 2D tile map, and this gives us a new layer to work with. So we could call this the background tile map. And then over in our tile palette, when we go to draw, we now have to make sure we either have the ground tile map selected or the background tile map selected. You can also do this by clicking over in the hierarchy to flip between the two of them. So if I have my background tile map selected, and then I use the paintbrush tool, I could actually select this. Whoops, I meant the rectangle select tool, and paint in a brick background. So we've got our brick background and we have our ground tile map, but they're not rendering in the right order. We want this ground tile map to be on top of the background tile map. And you might think that you could just like rearrange them in here and hope that that would do something. But actually we have to look at the tile map renderer component here. So both of these have this sorting layer section where we can choose where they are in sort of relation to one another. So right now they're both in the same layer. And one easy way, we could create another layer. We could create one for background and create one for ground. But for now, let's just go ahead and use the order. So if we change this order and we bump ground up by 1, now ground shows up on top of our brick wall. And now that I see these together, I don't actually want this brick wall as my background. There's a little bit too much contrast going on. So let's replace that background. Let's use this. I'm going to use the rectangle tool again to fill all of this in. And then over in the tile map component, there's this color. And we can actually use this color. We can adjust it to lower the contrast so that our platforms stand out a bit more. So you could reduce the opacity so that they kind of blend into the background color, or you could go ahead and sort of tint them a little bit darker so that our platforms stand out a bit. And that looks fine. So I'll leave it here. And I can see that some of these tiles have a little bit of transparency at the edges. And so I actually just also want to go to my main camera and make sure that my background color, that I choose a good color. Here I'm just going to make it black so that everything blends in nicely in our final camera view. So with this, let's turn our eyes to physics. So if we check out the asset pack again, there's a little example at the top here, and it looks like the player is about the same size as an individual tile in the map. And so let's keep that in mind as we go ahead and let's grab one of the frames of the player and drag it into the world and see that it's super tiny. And so this is because we changed our tile map, the terrain image, to be 16 pixels per unit, but we didn't do that for any of our other images. So actually what I'm going to do is let's do that now. I'm going to filter by texture and make sure that I'm in Pixel Adventure 1, select everything with Control A, and pixels per unit, let's say that's 16, and go ahead and apply it. So our dude will now resize and looks like is about the same size as a tile. You can see that we're going to have to change the sorting layer here. So same thing we saw before with our tile maps is that they have a sorting layer. If we look at our player, and let me rename this to be player, it also has an order and a sorting layer. Now that we have 3 things that we want to sort, let's actually, instead of using order in layer, let's go ahead and start creating sorting layers. So for this, maybe we need 3 sorting layers. We need background, ground, and foreground. And we'll put the player in the foreground, the platforms will be in the ground, and our grayed out kind of background will be in the background. So I'm going to add sorting layer. And this is different than layers that we've used previously in 3D scenes, and this is different than tags. So it's the sorting layers area. Let's go ahead and create ground, background, and foreground. And you want to make sure that these are sorted in the order you want them to show up. So I'm going to go ahead and put background before ground and foreground on top of ground. So now if I go to my background tile map, I can choose from the drop down the background sorting layer. I can now put this into the ground sorting layer, and I can choose my player and put it into the foreground sorting layer. And so now my player should show up in the right order in this scene. So that was a bit of setup to get to the point where we could actually add some physics to this player so that it can fall and land on the platforms. So let's do that. There are 2 things that we need when it comes to creating collisions. We're going to need a collider. So if we start searching for box collider 2D, that will give us a 2D version of a collider where we can hit edit and we can kind of drag our hitbox to match our player. And one recommendation that I have for you is people tend to find it more satisfying if your box is a little bit smaller than your player, as opposed to if you had made your box a little bit larger than the player. So you want to be a little bit more forgiving with your hitbox. So that looks about fine to get started for me. So we have our collider that defines the bounds of the object, and then we can add a rigid body 2D, and this is the 2D version of the 3D rigid body component that we've used before. And so now that we have those two things set up, if we hit play, we should see our guy fall, but because our map doesn't have any physics on it, the player doesn't actually land on anything. So let's fix that. I'm going to stop maximizing on play, and we want to go to our ground tile map because we don't need to do anything to our background tile map. That's fine. It doesn't need any physics, but our ground tile map does need some physics. So if we search for the tile map collider 2D, we can see that all of our tiles will now be outlined in green, and these are the colliding bodies for those tiles. So if we hit play, we should see our player finally land on our world, which is great. We've got some basic physics working, but this isn't perfect. There are actually some problems with this. So let me pull up another post that I made. So this is, again, in another game engine, but the same concept applies. So the top is a tile map where each tile is its own body, its own physics body, and then throwing some mushrooms over it. You can see that they catch on the lip between two tiles. And really what you want is for your world to have this nice single body over it, so that there's actually no lip for anything to get caught on. Like our player, as it's running along the platform, we don't want it to trip and catch on any of the lips. So Unity has given us a tile map, composite collider 2D. And so if we add this, it adds a rigid body and gives us this composite collider 2D. And if we check on our collider 2D that it's used by the composite, we can see that now instead of each tile individually being outlined, we've got the whole platform that we've created being outlined with a single body. So two more changes that we want to make. If we hit play at this point, because we just got a rigid body on our tile map, the whole map is going to fall away. So a rigid body 2D is defaulting to dynamic, and we want to change it to static, which means it shouldn't move in the world, but it should still participate in the physics simulation so other things can land on it. So that's one change we want to make, which should fix the idea of the map falling away. Great. The other thing that we want to do is go back to the player, and under collision detection for our rigid body 2D, when you have discrete collision detection, it's as if the physics engine takes like a snapshot at each moment in time. So if our player is moving from, let's grab the player here. So if our player moves, it's over here on one frame and it's over here on the next frame, the collision detection won't actually detect that the player just like moved through a wall. It will be as if the player has teleported from here to here, and that's completely fine to the physics engine. But for things that are fast moving, or for things that we really care about accurate collision detection, like a platformer, we actually want to use continuous collision detection. And so continuous collision detection, so if on one frame the player is here, and on the next frame it's projected to be here, what the physics engine will do is know that the player like swept from here to here, and will know that here is the spot that it should stop. So continuous collision detection will make your simulation more accurate at the cost of more expensive calculations. But in the case of this, like our player controller, we actually really want it to be accurate so that the player doesn't teleport through walls or glitch through platforms. One more setting that we want to configure on the player is actually if we move the player over to one of the edges of the platform and hit play. Let's move it a little bit further. There we go. It falls off. And that's because the player is configured so that it can actually rotate in our 2D world. And for a platformer, that's not necessarily something that we're going to want. So inside of our rigid body 2D, in addition to changing the collision detection, we can freeze the Z rotation, which means that now the player, as long as they are positioned over the edge, they should no longer fall and be able to rotate. So we've got something basic set up here now. and we can actually start scripting and building out the logic for controlling this player so that it can move when the player at the keyboard presses the arrow keys to move left and right, or presses the spacebar to jump. So we're going to start that in this video, and we'll pick it up in the next video and improve upon it. So I'm going to come over to my project here, and I'm going to create a new folder called scripts. And into that folder, I want to create a new C# script, and we'll call it player controller, and attach it to our player. Give it a second to finish compiling when we create the script for the first time. Got it added to my player, and I'm going to go ahead and open this up in Visual Studio. So got Visual Studio up. One thing that I want to show you all before we even get started on this is that we've used serialized field before as an attribute to go ahead and tell Unity that this field is private but should be configurable in the inspector. There are actually a bunch of other attributes that we can create. So I'm going to paste a comment in here that has a couple of links. So we've seen serialized field, but there are a few others that are really useful, like being able to hide in the inspector, create a tooltip, disallow multiple versions of the same component to be added. So in the Unity scripting reference, if we go here, in the sidebar, when it finishes loading, these are all the attributes that we can add. So I want to show you a couple as we're building this out so that we can kind of keep our code a little bit cleaner and make our components a little bit cleaner. So a few that we can actually put on the class itself. So these apply to our component. We can say disallow multiple component. And this means that if we tried to add back in Unity another player controller script, we're going to get an error because we've said that it can't have multiple. So that's handy. The other thing that we're going to want to do is we know that our player, how we're setting it up, it requires a rigid body 2D and requires a collider 2D to both be on here. But right now we could go ahead and remove a component and Unity will not complain. So we can flip back here and use the require component attribute to say we need a thing that is type of rigid body 2D, and do the same thing for collider 2D. And all of these could be on one line. I'm spacing them out on their own line so that it's a little bit more legible, but these all apply to the player controller. So now if we go back and we try and remove this rigid body 2D, it's saying, no, you can't do that because the player controller depends on it. So these attributes can kind of help us make our components a little bit more friendly. And we can apply them to fields as well. So I can serialize a field. And since this is a player controller, we're going to need some kind of speed. So I'm going to create a private float speed. And we've seen serialized field before. That applies to the speed field and makes it show up in the inspector. But we can also say add a header here, ground movement. And now if we save it and flip back to Unity, we can see the fields that we put under this header will now show up under ground movement. So if we had other things like we wanted to store friction, or we wanted to store like walk speed and run speed, those would be good to label with a header so that folks reading it will be able to see those grouped together visually. We can also add a tooltip here. So tooltip, and then in the argument we can put in like movement speed in tiles per second. 1 tile equals 1 meter in Unity World. And save that, and then if we flip back to Unity and hover over the speed, we get that tooltip showing up. So working in script inside of Unity, sometimes you're going to be designing components so that other people can use them, and all of these things help make your scripts, your components, more usable by other people. Let's create another field here for air movement, and this will be our jump force. And let's put a tooltip in there for the upward force applied when player jumps. Whoops, I missed a closing parenthesis up here. And then what we can also do is use the range attribute. And the range lets us say that this value should be between two things. So let's say it should be between 0 and 10 for the force. And then when we flip back to Unity, we get both a field that we can enter manually and a slider that we can just adjust, which is pretty nice for certain types of variables. So I'm going to configure this while we're at it. I'm going to say maybe the ground speed will be 5 and the jump force will be 3. So let's start scripting. Inside of here, what we basically want to do is check whether the left or right keys have been pressed. So that would be the horizontal axis. And then we can adjust the player's velocity based on that. And we're moving away from transform.translate here because we're working with a rigid body. And in general, you don't want to mix transform translate, transform rotate, things that we used previously, with the rigid body simulation. If you are using rigid bodies to control your characters, you should be all in on that, and you should be moving things by talking to the rigid body component. So you should be using add force, or manipulating the velocity direction directly, or use move position, or the rotation method. So those would be the things that you would be talking to move this character around. So what I'm going to do here is we're going to need a few fields. So we need to talk to the rigid body. So let's create player rigid body. And we also will need a Boolean to determine whether or not the player is jumping currently. And let's also add in, while we're at it, a Boolean is facing right equals true. So what we're going to set up is the rigid body. We will go ahead and get access to that. When we press the left or right key, we will modify the rigid body's velocity to move the player left and right. We will use a Boolean variable here to determine whether or not the player is currently jumping, so that we can kind of disable jump after the player has jumped once. And then is facing right is going to come in because we're going to need to be able to, when we move right, make sure that the player's sprite is facing right, and when it moves left, we want to flip it so that it faces in the opposite direction. So let's get started with the horizontal movement, and then we'll worry about jumping. So we need to make sure that we fill in the player's rigid body. So we get component rigid body 2D, and then we're going to let me make a note. So we'll fix this in the next tutorial, but there are two ways to hook into updates inside of Unity. There's the update, and then there's fixed update. And fixed update is actually where you want to apply your physics changes, because this happens in sync with the physics engine, and update does not happen in sync with the physics engine. We'll kind of get into this next time, but I'm going to make a note. To do, we should put our physics code in here, not in update. But just for today, so that we can get something working quickly, we're going to just use update. So we've seen before that we can get the horizontal input from the input get axis horizontal. And using that, we could go ahead and say this horizontal input is going to be a number between -1 and 1 based on whether they're pressing the left key, -1, or the right key, 1. And so we can use that to modify the player's rigid body. So we can reach in and say that the player's rigid body's velocity should be equal to a new velocity. And we can say vector2. We will go ahead and let's break this out into another variable. So let's say the float x velocity is equal to our horizontal input times our speed. So if the horizontal input is 1, we've pressed the right key, that means that we're going 1 times the speed, which would just mean we're going in the positives. Our velocity is positive speed. And if they press the left key, which would be -1, we are now at an x velocity of negative speed. So x velocity, let's plug that in here. And then the y velocity, we don't actually want to change that at all here. So what we're going to do is player rigid body dot velocity dot y. So we're just going to say it's equal to a new velocity where we're changing the x, but leaving the y in place. Let's go ahead and test that and see if this is working inside of Unity. So I'm going to grab my player, I'm going to hit play. So as I press left and right, the player moves left and right, and as I hold the right or left button down, the player actually like sort of picks up and gets up to speed, gets up to that maximum speed. And actually that acceleration, that's nowhere in our code. We didn't create that ourselves. That comes from, if we go to edit project settings and look at our input and our configuration for the horizontal axis, the gravity and sensitivity control how quickly our horizontal axis gets up to 1 or returns back to 0. And so those values you can actually tweak to get different kinds of accelerations with the current code that we have set up for our player. So right now this is great. We'll investigate how to do jumping. I think we'll save that for next video, but the last thing that we'll do here is make sure that when we move left and right, we actually flip the sprite. So what we want to do when we are moving right is leave the player as is, and when we want to move to the left, we actually want to take the player and flip it over the y-axis. Whoops, not the y-axis. We want to flip the player over the x-axis. So we'll go ahead and do that in code now. Let's flip back. And what we want to do is probably let's create a reusable method here called flip. And what we're going to do is take this Boolean variable. So if we're facing right, we will go ahead and make ourselves face left. And if we're facing left, we'll go and say we're facing right. And the way that we're going to do that is using the negation operator, which is going to take whatever this value is, flip it. So if it's false, it'll become true, and we'll store that back into is facing right. And then we're going to take our scale, vector3 scale. We'll grab our transform.local scale. We will modify the x. And we're going to use a ternary here. So we're going to say is facing right. We will go ahead and set it to 1. Otherwise, we will go ahead and set it to -1. And then we can put this back into our local scale. And this, equals scale. And this ternary operator, if you haven't seen this before, it is equivalent to writing an if statement where we said if is facing right, scale.x equals 1. Else scale.x equals -1. This is our condition. This is what happens if it's true. This is what happens if it's false. So a ternary is just a terse way to express that same logic. So we've got our flip function, and now we just need to hook it up. So what we want to do is determine when we need to flip the character. So if we are currently facing right, and our horizontal input has just gone less than 0, meaning we're trying to go to the left, we should definitely flip our sprite. And we also want to do this same thing for if we are not facing right. So this would mean we're facing left, and the horizontal input has now just gone above 0. So we would now need to say, okay, they're trying to move to the right, so we need to flip them. And we could do this as 2 separate conditionals, but actually it would be better to just combine this into 1. So I'm going to wrap this in parentheses, put an or at the end of it, and then grab our other condition here. So we're saying if we are facing right and the player is trying to move left, or we're facing left and the player is trying to move right, then we need to do a flip. So let's go back to Unity, give it a shot. There we go. As we move left and right, the player flips to look in the direction that we're trying to move. Okay, so to review real quick, we saw how to process our assets so that they could be configured for a 2D game. We learned how to change the pixels per unit. We learned how to slice things. We learned how to control the scaling so that we set it to point with no filter. We learned how to create tile palettes that allowed us to draw and create multiple tile maps composed of tiles. We learned how to use some of the 2D components that correspond to 3D components that we've used before. Like we learned how to use the rigid body 2D instead of rigid body, and the box collider 2D instead of box collider or cube collider that we've used before. And we were able to put all that together with a little bit of scripting to create the very bare bones of our platformer moving around. So right now, this isn't complete. We'll pick it up next week, but we can at least move around a world, and next time we'll learn how to jump and add some more compelling level design.